How does React 3 Fiber actually work under the hood? Maybe you have a great Three.js foundation, but bringing this to React has been challenging. Or maybe you're like me who came from the React background, but finds the Three.js world a bit much to understand. This video was created for both of you. What I'm going to do today is walk you through a side-by-side, one-to-one build of a Three.js project and a React 3 Fiber project at the same time. Sometimes the best way to understand a library like React 3 Fiber is to compare it to the OG, tried and true Three.js library so you can see exactly what's happening on each side. We're going to start by creating a scene on both the 3 and the React 3 Fiber side. Specifically, we'll talk about how cameras work, meshes and their geometries and materials, animation and lighting, and how all these are implemented within JSX and how they actually work within React. We'll dive into the little tricks that React 3 Fiber does to make your renders look nice, including anti-aliasing, tone mapping, and color output. And then we'll toss in a couple extras just for good measure. Alright, so we got our two environments side by side here. On the left we have Three.js, and on the right we have our React 3 Fiber. We're going to start on the Three.js side first, just because there's a lot more involved in the setup, whereas React 3 Fiber wraps a lot of this for us. First, we need to create a scene by creating a new scene instance. For those not familiar with Three.js, the entire library consists of classes that you can create instances of. Next, we have our camera. In this case, we're going to use a perspective camera with these defaults. These arguments refer to the field of view, the aspect ratio, the near frustum, and the far frustum, which is talking about at what point does the scene get clipped. These are the default values that React 3 Fiber uses, so I'm just going to put them in there so that we can have identical scenes. Next, when you're building a Three.js project, you're going to need to create a renderer. Three.js supports multiple renderers, the most common being the WebGL renderer, so we're going to use that. And by default, it does not have a transparent background, whereas React 3 Fiber does, so we're going to turn alpha to true to enable that, otherwise it would be a black canvas. We're going to set the renderer to the window inner width and height, and then we are going to append it as a child on the web page. This is a Next.js project, so that's why I'm using this element as my container. And then finally in 3, we need to have our render loop, which is accomplished through this pattern where you have a function typically called animate. You call request animation frame from the browser, and then every frame it will render the scene. And with the request animation frame, that will call animate every frame available the browser provides us. And then of course we need to call animate at the very beginning, otherwise nothing kicks it off. So this is the Three.js side. On the React 3 Fiber side, as you can see, much simpler to start. We just have our canvas. Note that this isn't an HTML5 canvas. This is a special React 3 Fiber canvas that we're importing from their library. At this point in time, we have no children, so let's go ahead and get started by adding a mesh. So let's come back on the Three.js side, and we're going to add a mesh to the scene. In this case, let's add a cube. In Three.js, your mesh needs to have a geometry and a material in order for it to appear on the screen. So we're going to add a new geometry. We're going to use a box geometry so that it shows up as a cube. The parameters expect a width, height, depth, and additional parameters. By default, the width, height, and depth will be 1, which works for us. And then we're also going to add a material. And for now, we're going to use a mesh standard material, which has a default color of black. To add that to the cube, we're just going to say cube.geometry equals geometry. And we'll do the same with our material. And then finally, if we want to see the cube on the screen, we need to do a scene dot add our cube. And when we save that, we don't see anything. Why don't we see anything? Well, by default, our camera is at the 0, 0, 0 position, 0, x, 0, y, 0, z, and so is our cube. So our cube and our camera are on top of each other. So what we're going to do is we're going to move our camera back by setting its camera.position.z to 5, which is the default that React 3 Fiber sets it as. Now we can see our mesh. On the React 3 Fiber side, we're going to go ahead and do the same thing. So to add a mesh, it's a simple JSX element called mesh. And then to add our geometry and material to it, they're simply going to be children of the mesh. So in this case, we're going to have a box geometry, and we're going to have a mesh standard material. So you might be thinking, hold on, you just planned this perfect example, but this doesn't really explain how any of this actually works. Like, where is my scene on the React 3 Fiber side? How does the camera work? I don't see that in here. We did the rendering. Where is the rendering? And my response to that is, you need to calm down. Do you know what channel you're on? Of course, we're going to go over that stuff. So let's start with the scene. Three.js, we have to create a new scene, and then at the bottom, we are rendering that scene within our animation loop. React 3 Fiber, this is all handled for us within the canvas. Since React 3 Fiber is trying to make Three.js accessible within the React ecosystem, this is something that generally most people don't want to manage themselves and don't need to manage themselves, so they abstract this for us. And React 3 Fiber does a pretty good job of choosing things that you normally don't really want to have to worry about, but still giving you the option to tweak those things if you really wanted to, which is best case scenario. So pretty sane defaults. So Canvas is creating a scene for us. What about the render loop? They are also doing that. So this animate, request animation frame, that's all being handled within this Canvas component. We don't need to worry about that. Okay, what about cameras? So cameras, again, we're explicitly creating that on the Three.js side. On React 3 Fiber, camera, again, is being created for us within the canvas. And why is that? Why don't they require us to create the camera here ourselves? It feels like maybe that could be a little bit too much magic happening, but I think it's a good amount of magic because if you come down here again to the animation loop, this render function explicitly depends on the scene in the camera. So if this camera was something that we added to the scene ourselves, then that makes it complicated for React 3 Fiber to also manage this animation loop for us. So after understanding that, I think it's fair that the canvas actually manages our camera for us. And if you're wondering, well, what if I want to manage the camera myself? No problem. There's actually a couple options. Number one, you can manage it through a prop on the canvas. You can go camera, and then this is props passed to that camera. So for example, you could set the position, and by default we have 0, 0, and 5, which is matching what we have here, which is camera position Z5. If I save that, nothing will change. If I were to make that 10 and refresh this page, then you can see we move back further in the Z direction, and that behaved as we expected. So let's go ahead and actually just remove this. You'll notice that the hot reloading doesn't apply for the camera. That just has something to do with the way the props work. If you want to manage the camera as a JSX element, you can, and you can do that by importing a special component called you guessed it, perspective camera, but this one comes from the React 3 Dre package. React 3 Dre is a separate package by React 3 Fiber that holds a bunch of goodies for React 3 Fiber. So React 3 Fiber itself is just the minimal core to get Three.js working within React, and then Dre provides a lot of extras to assist with it. So we just insert the perspective camera here. We're going to add a field of view to make it match what we have on the Three.js side, so that's 75. And then we need to give it a position as well to match the Three.js side as well. The perspective camera component from Dre will default to just 0 for the position. So let's change that to 5. We also can't forget to say make default true, which will override the original default camera and make this camera now the active camera. So if we save that, and then we can now change this to anything else, and we can see it update in real time. This perspective camera does work with hot reloading within React. So we're going to get rid of this and go back to our original setup. So next, let's talk about how React 3 Fiber treats Three.js elements within JSX. So starting with the canvas, you can basically treat the canvas as the scene in this context. Anything that's added to the root level within the canvas will be added to the scene. So in this case, we have our mesh, and just as we do in the Three.js side, we're adding our cube to the scene. That's the exact same thing as what's happening here. This mesh is getting added to the scene. And then from there, any nested children will get added in the same way. For example, if I were to add another mesh inside of this mesh, which is, to be honest, not that common. But if you're to do that, then that would be equivalent to saying mesh.add another mesh. So in this case, say I had a cube and then I had another mesh equals new mesh. Then I could say cube.add another mesh, and that would actually add another mesh as a child to cube. And you can see that's equivalent of what's happening on the React 3 Fiber side. Now, in general, you're not going to be nesting mesh elements. You certainly can if you want to. More commonly, you'll probably see what's called a group, and then you can have multiple meshes inside of a group, and then groups have their own position, rotation properties that can allow you to move all its children as a whole. From the Three.js side, this is not a new concept. You would just create a group, and then you'd say group.add cube, for example. So then how does box geometry and mesh standard material work? Since these are children of mesh, are these actually getting added in the same way you'd say cube.add geometry? And that's not true, right? You don't add geometry as a child of cube. You set its geometry property and its material property. So how come these two JSX elements get special treatment? How do they actually work? And to answer that, you need to understand a pretty key concept in React 3 Fiber, and it's called attaching. So essentially, React 3 Fiber behaves like this. Any child of an element will be added with the .add function, unless they have a special property called attach. If they have the property called attach, then instead of being added as a child of its parent, it'll actually get added as that property of the parent. So in this case, if I say attach geometry, that's saying add this box geometry to the geometry property of the mesh. So in this case, you can see over here, cube.geometry equals geometry. That will actually attach it. Same with the material. I could say attach equals material, and it will attach this mesh standard material to the material property in the same way we are doing on the left-hand side here. Now, how come I didn't need to do that before? Well, for convenience, React 3 Fiber automatically attaches all geometries that end with the word geometry to the geometry property, and all elements that end with the material to the material property. And that's just to make your life easy, because these are things that you'll be adding all the time. The last thing to understand is the naming behind all the Three.js elements within React 3 Fiber. So you may have noticed that we follow this camel case that has a lowercase first character within React 3 Fiber, and then within Three.js, we of course follow the standard class-based Pascal case with the capital at the beginning. And so you may be wondering, can I literally just one-to-one for every Three.js class that exists do the equivalent within JSX just with the difference of changing the first letter to lowercase? And the answer is yes, that's basically correct. An important note when it comes to React 3 Fiber is that React 3 Fiber actually knows very little about Three.js. And that might sound kind of crazy, but the way React 3 Fiber works is it actually just simply takes this object and finds a Three.js equivalent and then inserts it, right? It by default tries to add children using the .add function unless it sees the attach. If you go and actually look at the React 3 Fiber renderer, which is their actual reconciler code, the way they actually convert JSX within React to something React understands, you can see that it's actually very, very simple. And React 3 Fiber at its core is just a very thin wrapper around Three.js. And the reason why this is so important is because, especially for those who are coming from the React side, people who understand React relatively well, but they're trying to dive into the Three.js world, you really need to understand that React 3 Fiber isn't doing anything special. It's literally just putting normal, regular, vanilla Three.js components within the React ecosystem, but they're not creating anything special unless, of course, you're pulling additional components from the React 3 Dre package. Those are more or less new things, but React 3 Fiber itself is actually not doing anything special. And this is really important when you're first getting started, because if you're anything like me, who is somebody who started with React and really didn't know anything about Three.js and then tried to dive straight into Three.js within the React 3 Fiber library, I almost kind of expected React 3 Fiber to give me all the documentation, give me all the instruction necessary to build a 3D world within React. And that's really the wrong approach. You want to first and foremost understand how Three.js works, and then from there it's much easier to build it within React, because all React 3 Fiber are doing again is taking Three.js concepts and making them work within a React ecosystem. But to actually build within the Three.js world, you need to know Three.js first and foremost. And why did React 3 Fiber decide that these should be camel case instead of Pascal case? AKA, how come the first character is lowercase? Well, that's convention for React. If you're familiar with React for the DOM, all your divs, H1s, A tags, everything is lowercase by default. And that's the convention for any element you consider primitive, right? So React 3 Fiber follows that exact same convention. All the primitive components, in this case primitive with respect to Three.js, are going to follow that first letter lowercase convention. So in summary, React 3 Fiber JSX elements map one-to-one to the respective Three.js component. Children within JSX elements are added to its parent via the .add function, unless they have a special .attach method, which in that case gets added to the respective property that you chose, with geometry and material nodes getting special treatment because you use them all the time. Because of this, technically nothing stops you from using things like vector3 in here if you wanted to. Now, I've never seen anyone actually do that. This doesn't make sense. You can't add a plain old vector3 to a mesh. But if you're familiar with Three.js, you can create vectors, and you'd say new vector3, for example, which would consist of an X, Y, and Z. And I could easily add that in here. And nothing stops me from adding that in here if I wanted to. Of course, I need to have a reason for it. In this case, this would not work because Cube can't add a vector3. But hopefully this helps you understand a little bit more about what's actually happening under the hood when it comes to React 3 Fiber. The last thing we need to talk about real quick is arguments. So in Three.js, I haven't been using arguments. I've just been using the defaults. But if you can imagine, we have our box geometry, and the arguments that this constructor expects are width, height, depth, and a bunch of other things. So let's say I want to set my geometry to be 2 by 2 by 2. Let's save that. So our box is twice as big. How would I do the equivalent on the React 3 Fiber side? Well, React 3 Fiber has a special prop called args, and this will exist on nearly every single element. And this expects an array, and this will literally get passed in as arguments to the constructor of the component that you're trying to build. So in this case, I would say an array of 2, 2, 2. And under the hood, literally, this is an array that's getting spread into the arguments, if you can imagine like this, of the relative component. So if I save this, we can see it went ahead and changed the box geometry to be 2 width, 2 height, and 2 deep. It's not going to be long until you're going to want to start componentizing your objects within the 3D scene. So, on the Three.js side, since we're using more or less vanilla JavaScript here, you can basically componentize your objects however you like, though one common pattern would be to use classes to do this. So for example, we create a class called RCube, and this would extend a mesh, and then within the constructor, we might create our geometries. Within React 3 Fiber, this would of course just be another React component. So let's talk about animation. In Three.js, you might, let's say, rotate this cube in a circle by modifying its rotation within the animation loop. Since we've abstracted this cube into a component, we'd want to move this logic into that component. Typically, you do this with a function called update. Then we just need to make sure we call update on the cube within the animation loop. And now we have an animating cube. Now, how do we do the same thing in React? So React 3 Fiber gives us this nice hook called useFrame. And you can think of this useFrame hook as behaving almost exactly like our update function on the cube. Every single frame, this function is going to get called, and you can do whatever you like with it. So in React, we need to somehow get access to this mesh in order to modify its rotation X and Y like we've done in Three.js. To do that, we can use refs. Perfect, now we have a rotating cube in React as well. So there's two things we need to talk about here. So first off, what really is a ref with context to Three.js? Well, in React 3 Fiber, the ref on each JSX element is literally going to point to the exact instance created within Three.js. So attaching a ref on this mesh is literally going to point to the exact Three.js mesh instance. The same thing would apply if I were to add a ref to the geometry or the material. That would point to an instance of that geometry within Three.js. If you've used refs within regular old React on the DOM, it behaves the exact same way. If you were to add a ref to a div, you literally have a reference to the instance of that div within the DOM. Okay, second thing to point out is if you're OCD like me, the left-hand side Three.js is probably driving you crazy right now. Why is that looking so pixelated, whereas the React 3 Fiber one is looking really smooth? Don't worry, we're going to talk about this in just a little bit. By the way, there are other ways to animate within React 3 Fiber. Specifically, there's a library called React Spring, which integrates seamlessly with React 3 Fiber. React Spring essentially allows you to create animations in a much more declarative way, and is actually cross-platform, works in the DOM, works on React Native, and works in 3, of course. But we'll save that for another video. Before we add lighting to the scene, I want to bring up one last point, and that is around disposing. If you've used Three.js before, you might be familiar with disposing, where Three.js actually requires you to manually dispose your geometry and material, for example. And the reason for that is because usually you would cache these and Three.js doesn't know when you are done with them. So one thing you might do is add a dispose function, and then you would dispose, for example, your geometry here and anything else that you would need to dispose. And then at the time that you want to get rid of your cube, you call that cube.dispose. Within React, we actually don't need to worry about this at all. And that's because React actually already understands the exact life cycle of all the different components within React. So React 3 Fiber takes advantage of this and actually will automatically call dispose for you when elements are removed from React. Pretty handy. All right, so let's add some light. An ambient light in Three.js is a light that is spread evenly across all objects. Let's do the same in React. Let's also add a point light so that we can add a little bit more dimension to the scene. Point lights exist within a very specific position on the scene. Now that didn't seem to do anything. We'll come back to that in a second. Let's add it on the React side. And now we can see, at least on the React side, we're actually getting a bit of dimension here. Okay, so why is the React version looking so much better than the Three.js version? So now is a great time to talk about the rendering appearance, and there's a number of different ways we can configure how Three.js will appear when rendered. So first of all, let's address this pixelated look. You can fix that by adding another property to the WebGL renderer called anti-aliasing. This actually isn't on by default within Three.js, however it is within React 3 Fiber. So if I save that, we're already looking a little bit better. Still not perfect though. It looks a little bit fuzzy on the edges here where it's quite crisp here. And this has to do with the pixel ratio. So by default, Three.js will render at a pixel ratio of 1, whereas React 3 Fiber will try to match what your browser supports. So we'll have to manually do that within 3. So that looks a lot crisper now. We still have a flat white looking box compared to the 3D one on the React side. And this has to do with tone mapping. And by default, React 3 Fiber chooses to use the ACES filmic tone mapping, which we'll use here. Okay, so finally we have a 3D looking object on the Three.js side, but it still looks a little darker than the React 3 Fiber side. And that has to do with the color space that Three.js is outputting. We can fix that by setting the output encoding to the sRGB encoding. And now our cubes are looking identical. So why does React 3 Fiber have different defaults than Three.js? Well, React 3 Fiber is making the decision here that they want to provide defaults that they think majority of people will want. And setting this tone mapping and output encoding to these values achieves that. Of course, nothing stops you from changing these if you want to. Within React 3 Fiber, you can get access to the GL renderer through the GL prop on the canvas, and you can set your configuration there. Of course, our cube would not be complete without adding some color. So let's make our cube blue. Three.js, we can do this by setting the color on our material. So we could go ahead and set the color within the constructor. Or alternatively, we can set the color on the material itself. In React 3 Fiber, it's done similarly, where color would be a prop on the mesh standard material element. Or if you wanted to be absolutely crazy and do something absurd, we could actually add a color as a element within mesh standard material and use our attach prop to attach this color to the mesh standard material color property. Please don't do this. I see almost no value of making this an actual child of mesh standard material, but I'm just trying to really demonstrate what kind of options are available within React 3 Fiber once you understand a little bit more how the JSX elements work. Okay, last thing we never addressed here is how this array of 3 values, also known as a triplet, actually works. From the Three.js side of the world, you don't really see this convention that much, so how come we're using that all the time within React 3 Fiber? And to answer that, you need to understand how something like position actually works within Three.js. So when I create a new point light, for example, it's going to have a position. This would also be true for most any other thing within the scene, like your mesh would have a position, groups do, etc. So looking back at our point light, if I hover over position, you can see that this is a vector 3. Now, I never created this position. As soon as I create a new point light, that position is automatically added to the point light for me. And under the hood, what's actually happening there is this position will create a new instance of a vector 3, which we talked about before, consists of an X, Y, and Z value. Another thing worth noting here is I can't just assign a new vector 3 to my position. As you can see here, position is a read-only value and cannot be reassigned. So the way that you actually would change your position is instead of overriding the vector 3, you would just call set on that vector 3. And there's good reason why this is the case. Vector 3s aren't necessarily cheap to create. You can imagine vector 3s are used all the time within Three.js. All the position needs vector 3s and many other things. So if every time we wanted to move an object around, we had to create a brand new vector 3, that'd be extremely expensive. So instead, we're just mutating that vector 3 by calling set. So how does this translate to the React 3 Fiber world? Well, if we look at the type of position here, we can see that it's a vector 3, which is interesting. If we actually drill into that, we can see that this is actually a special vector 3 wrapped by React 3 Fiber that allows you to input a number, an actual vector 3, or this triplet notation. So technically, I actually could put a new vector 3 in here with my values, and this would work. Now, this is an anti-pattern within React 3 Fiber for the exact same reason we just talked about. Within React, you should know that the code within this functional component will be called every render, and if we are creating a new vector 3 every single render, this is going to be extremely expensive and not performant at all to run. So instead, best practice would be to do what we did originally, which is this triplet notation, and an array of 3 values is relatively cheap to recreate every render, but this still feels a little bit like magic. How is this triplet of 3 values getting passed into my point light's position? Well, almost like the args, what's happening here is this array of 3 values is actually getting spread into the set function of position. So what React 3 Fiber has done here is they do allow you to use vector 3s, and if you cache them properly, that's reasonable. But in order to take advantage of the declarative nature of React and allowing you to be changing the values within JSX, pretty much every property that's available on these objects allow you to use these different notations, and specifically this triplet notation you can use, which will always be spread into the set function of that respective prop. So there you have it, Three.js and React 3 Fiber side by side. I hope this video has helped you really understand what's happening in React 3 Fiber. I really enjoy making these videos, but they do take a lot of time and effort. So if you found this video useful and would like to see more, liking the video and subscribing would no doubt help with that. Have a great day, and I'll catch you down the next rabbit hole.